Hello everyone. I hope you guys are well and safe during this pandemic. Well, I'm Nilo Ahmed Pulok, and today I would like to give a brief presentation on the topic reverse breakdown of semiconductor diodes. So before doing that, let me give you a very small introduction about me. As you know, I'm Nilo Ahmed Pulok, and this is my 7th semester, and my student ID is 193975551. So let's go to the topic. So why breakdown of a semiconductor occurs? So it is basically because we increase the applied reverse voltage across the diode beyond a limit. So what it means is that the breakdown of a diode occurs during its reverse bias conditions, as we all know, and under reverse bias the positive terminal of battery is connected to N side and negative side terminal of battery is connected to P side. So as a result, electron will draw towards the terminal of N side and holes will draw to the terminals of P side. So at this condition, electron hole combinational recombination will not happen, and hence majority carrier movement is absent. So this is the reason a diode is not conducting under reverse bias condition. So if we keep on increasing the applied reverse voltage, the depletion wide will increase accordingly, and at a point which we can call as breakdown point, the diode will get damaged. So at this point, the diode behaves more like a shortened wire, and hence current flow through it easily. So the internal resistance of diode at this stage is approximately near zero. So according to Ohm's law, as we all know, that V is equal to I by R, and since resistance is very low, current increase may force with voltage. So this is the reason we get a perpendicular lines in the diagram. So if you look at it, it is quite self-explanatory, and we'll be focusing on the reverse diodes, and that line actually describes the whole situation. So now we came to the point that why breakdown of a diode occurs. It's because we increase the applied reverse voltage across the diode beyond the limit. So what are the whole PN junction diode breakdown can be actually divided into two parts. It's L-Van-C breakdown and the Zener breakdown. So these phenomena we'll be discussing these phenomena. So first, look at the L-Van-C breakdown. So L-Van-C breakdown occurs in a PN junction diode which is moderately doped and has a thick junction, means that its depletion layer width is high. And L-Van-C breakdown occurs when we apply high reverse voltage across the diode, obviously higher than the Zener breakdown voltage, and so we increase the applied reverse voltage. The electric field across junction will keep increasing. So this generated electric field exert a force on the electron at a junction, and it frees them from the covalent bonds. So these free electrons will gain acceleration, and it will start moving across the junction with higher velocity. So this results in collision with other neighbor atoms, and this collision in high velocity will generate further free electrons. So these electrons will start drifting, and the electron holes pair recombination occurs the junction. So this results in net current that rapidly increase. So what we can say that L-Van-C breakdown occurs in a PN junction diode which is moderately doped and has a thick junction, and it also occurs at a high voltage which is higher than Zener breakdowns voltage. Let's go to the next part, which is Zener breakdown. So when we increase the reverse voltage across the PN junction diode, what really happens is that the electric field across the diode increases, both internal and external. This results in a force of attraction on the negatively charged electron at junction, and this force frees electron from its covalent bonds and moves these free electrons to conduction band. So when the electric field increases with applied voltage, more and more electrons are freed from its covalent bond, and this is in results drifting of electrons across the junction, and electron holes recombination occurs. So a net current is developed, and it's increased rapidly in electric field. So Zener breakdown phenomena occurs in a PN junction diode with heavy doping and thin junction, which means that depletion layer with width is very small, and Zener breakdown does not result in damage of diode. So since the current is due to drifting of electron, there is a limit to the increase in current as well. So that was the whole presentation, and thank you so much for your time. I really hope you guys enjoyed this presentation.